Today, I'd like to present you about wood aging by using aged wood from Japanese historical buildings. At first, I will introduce Japanese wood culture to share with you about the situation of preservation of Japanese wooden structure and give a talk about wood aging. The first topic is aging effect on mechanical property, that is, knowledge of wood science. And the second one is traditional perspective of Japanese woodworkers. And then I will show you some example of application of this research for conservation of wooden cultural properties. Japan is an island nation lying off the east coast of Asia. About 70% of Japan's island area is mountainous. Since the climate differs greatly between different regions of Japan, plant life is both complex and diverse. Of Japan's 4,000 or so kinds of plants, around 1,000 are peculiar to our country. Wood has always played a major role in Japan culture, and wood is used in more than 90% of buildings listed as national properties of Japan. So you can see here the world's oldest wooden structure still standing is Horyuji Temple, built in 7th century. Many historical wooden buildings over 1,000 years old still exist in Japan. The ancient capital Kyoto have many traditional wooden buildings, some of which are also listed in the UNESCO World Cultural Heritage Register. The restoration and conservation of historic buildings by Japanese government started in 1897. Principally, the restoration practice for historic buildings in Japan is characterized by its adherence to original technique and materials, and also for its minimum replacement of members by new ones. As a result, its replacement by a selection of methods, which preserve the buildings for the future without altering their structure and designs. We visited historical buildings under reconstructions to collect these aged wood samples, and wood species of these construction materials are also the identification of wood species of the building member has been often identified by carpenter's naked eye, but even skillful carpenters might make errors, especially in the case of old timber. That is why wood species must be identified scientifically by these optical microscope anatomical features to understand the right wood species in the right place by tradition. These are optical photomicrograph of hinoki, Chamaecyparis obtusa, softwood, traditional construction material in Japan. Hinoki wood is traditional construction material in Japan since the beginning of the 7th century. A document of Chronicles of Japan written in 8th century mentioned that hinoki wood has been kept worse for building. Japanese social and economic structure changed and centralized in the beginnings of 17th century. One could draw a line at the 17th century in the center in terms of the selection of columns in the historical buildings as presented in figures. Before the boundary, the major construction columns were made by hinoki, Chamaecyparis obtusa, whereas afterwards many species have been replaced. That may be partly because the advanced tools extended the range of species available for constructions, even from hardwood like keaki, zelkova serrata, and partly because the Tycoon Tokugawa family restricted the usage of the superior hinoki to their related infrastructure. So let's move to the main topic, wood aging. The general purpose of this study is to evaluate the wood aging. The degradation of wood is in general classified into 3 categories: weathering, and biodegradation, and aging. Now we can have the biodegradation discard, so I'd like to be in charge of wood aging part. Aging is also an important subject for the conservation and restoration of wood and cultural properties. It's my intention to describe the aging of wood. So before the experimental part, let me refresh your memory on the life of wood. A famous traditional Japanese carpenter, Mr. Nishioka, said, "Wood has two lives." The word meaning is the first life of wood as a tree and the second life of wood as a construction material. The information of a tree life could be known by dendrochronology and radiocarbon dating. And the information of a second life or construction material life also could be known by tool traces on the surface and archival survey. Sample specimens are wooden members provided from restoration sites of historical buildings which are replaced and were no more useful. So we give us the third life as a specimen for this study to create collective wisdom of wood science and traditional wood works. What you see here is aged hinoki specimens of this research from historical buildings. For example, the oldest temple, Horyuji. They are collected from historical buildings under reconstruction with historical information. To have precise dating using in both methods, dendrochronology and radiocarbon dating. This is an experimental test as follows. These are results of the 3-point bending test. Shown your left is typical stress strain curves of this experiment. Rigidity, this is the slope. Strength is maximum value. And rupture energy, this area, are calculated from each stress strain curves. So, these results said that slight drops in rigidity, strength in both longitudinal and radial direction. And you can see drastic drop of rupture energy, especially in radial direction. So, its conclusion of this study part, data on ancient wood can be used for the long-term prediction of aging effect on the wood properties, slight drops in rigidity strength, and drastic drop of rupture energy. So, practical conclusion is, all the structure members are safe unless submitted to unusual transverse loads, and restoration operations should consider compatibility between old and new wood. And we will move to the next topic. To evaluate the wood aging, I like to think about traditional perspective of Japanese woodworkers. As you can see here, some samples of restored Buddhist statues. So sculptures have various qualities of timber according to the tree species and the ages of the material used for the statues. So I'd like to know how woodworkers face these differences when they restoring statues. So as you see here, they are quite typical Japanese tool for woodwork, nomi. The way sculptor uses chisels, the upper two chisels is for old wood, and other two chisels for new wood. The sculptors are using these different type of nomi depend on the ages of materials in different ways. For example, sculptor uses nomi with quite sharp edge of blade for aged wood, like this. Therefore, we change the cutting force of several aged wood by using this equipment. The experimental conditions of test are as follows. So these are results. A blue line is new wood, a red line is aged wood. It means new wood is required high cutting force than aged wood when it uses the same blade in the same conditions. After cutting test, the chips were produced. As you can see here, suitable conditions for materials gave the rolling chips. So, its conclusion of this study part. So, as you know, aged wood increase of brittleness. So, restoration operations should consider compatibility between old and new wood. So, optimized cutting conditions were selected by traditional wooden workers with their experience. This traditional perspective and method is reasonable by this measurement. So at last, as you are about to see, mechanical and chemical characteristics of new wood is different from that of aged wood. So interface between original cultural assets and restored materials become stressed by restoration using new wood. To solve this problem, artificial aging that is thermally treated wood were useful for the restoration of wooden sculpture. That is assumption that aging caused by oxygen in the air. Artificially induced aged wood by thermal treatment opened new aspects in restoration of cultural heritages. Changed color and reduced mechanical and hygroscopic properties was found to be preferable for restoration. It's a case study of our basically researches using artificial aging wood, thermally treated wood. At last, I'd like to introduce our study group of wooden cultural properties in Japan Wood Research Society. A Japanese wood scientists who are interested in wooden cultural heritages gathers to have meeting and study tour to create collective wisdom of interdisciplinary scientists' knowledge and traditional workers' experiences. Our network is always open to you. That is contact address. And finally, it is not scientific talk, but last minute I'd like to talk this topic. So before my lecture about wood aging to Japanese children, I asked, what do you think the meaning of two leaves? So what wood has two leaves by Mr. Nishioka. So I like to ask the children what does mean this word. The children answered to my questions. That meaning I'm not alone, I can live with other people. Or I have a body and a soul in myself. I was born from both my mother and my father. In my body, they are the past and the future. These are children's answers. So, I believe a bright future awaits children with wood all over the world. That's all for my presentation. Thank you for your attention.